The safe is cracked, the briefcase is secure, and you've successfully taken the information that your boss will pay $1 million for. You are then silently sneaking out of the house, your presence undetected, until...
Ah!
From there, your heart starts to beat faster, your breathing picks up, and you begin to sweat like crazy. You now start to make irrational decisions, and without thinking, your survival instincts kick in. What you are experiencing is short-term stress, and this isn't your typical I forgot my homework type of stress. This is more of a my life will be over kind of stress. So how does this happen, and why does this happen? First, let's acknowledge that short-term stress isn't always bad. Now, I know you're probably thinking, but what? Doesn't this contradict everything I think? Like, my mom says it's bad, my dad says it's bad, Barney says it's bad, and, well, that's true. That anxiety that you gain can save you from a life-threatening situation, such as running away from the police. Specifically, your autonomic nervous system is the part of your body that helps you escape imminent death. Although, how does the autonomic system work? Well, our bodies are composed of two systems, which are the central nervous system, which is your brain and spinal cord, and the peripheral nervous system, which is essentially just everything else. From there, we can go further and divide the peripheral nervous system into the somatic and autonomic nervous systems. The autonomic system is responsible for making automatic decisions. It's in the name. But it can be split deeper into the sympathetic and the parasympathetic nervous system. The sympathetic nervous system is a system that is activated in stressful situations, and it's often referred to as the fight or flight response. The fight or flight response is whether you want to fight the threat or run away from it, both of which's goals is to put you in safety. So before we dive into how the sympathetic system works, let's clarify some things first. There are two chemicals related to stress, which are neurotransmitters and hormones. Neurotransmitters are chemicals used to communicate with other neurons or effector organs, like your heart or muscles, and they do that across a synapse, which is the gap in between a neuron. Hormones, on the other hand, are secreted from glands, and they flow through your bloodstream to effector organs to stimulate them. Both of these chemicals react accordingly to two different types of stress, which are short-term stress and long-term stress. Short-term stress uses your nervous system, while long-term stress uses your endocrine system, which is a system that regulates hormones. Between them, short-term stress is faster, but shorter, since it uses neurotransmitters to send signals, and long-term stress is slower, but longer, since it uses hormones to send signals. So you could think of short-term stress as a 400-meter sprint, while you could think of long-term stress as a 5K marathon. Now, the goal of short-term stress is to send a signal to the adrenal medulla, which is located in the middle of the adrenal gland above the kidney. And the goal of long-term stress is to send a signal to the adrenal cortex, which is located in the outer region of the adrenal gland. When stimulated, the adrenal medulla secretes amino acid-based hormones called epinephrine and norepinephrine, while the adrenal cortex secretes steroid-based hormones like cortisol. But you don't need to know about steroid-based hormones. Fun fact though, epinephrine and norepinephrine can act both as a neurotransmitter and hormone in different situations when dealing with short-term stress. Remember that. So, in conclusion, short-term stress uses the nervous system, it's quick yet short, and it stimulates the adrenal medulla to secrete epinephrine and norepinephrine, while long-term stress uses the endocrine system, it's slow yet long, and stimulates the adrenal cortex to secrete cortisol. Now that you're an expert in the difference between short-term and long-term stress, let's get into how short-term stress works. So, how the sympathetic nervous system functions is that when you're in response to a stressor, like knocking that vase over the table, neurons of the sympathetic nervous system detect that you are in danger, and they carry a signal from your hypothalamus down your spinal cord through the preganglionic nerve fibers, which are just nerve fibers that help transport the signal faster to reach the ganglia. Now, I'm gonna assume that you understood none of that, so here's an analogy to help you. Disclaimer, this is not my diagram, this is Crash Course's diagram, because I can never make a diagram that well. Moving on. Imagine a scout, who represents a sensory nerve, detecting an upcoming threat that could potentially harm his base, which represents your body. He will report back to his primary base, which represents the hypothalamus, and he will receive directions to his secondary base, which is the ganglia, to deliver the information he saw. To get there, he would have to drive through the spinal cord region, specifically through the preganglionic nerve lane, for the fastest route to reach his second base, with the intention of getting to the ganglia as fast as possible. Now back to reality, the ganglia are composed of clusters of neurons, and when the incoming signals reach the synapses inside the ganglia, which is the spaces in between the neurons, they release a neurotransmitter called ACH, or acetylcholine, and only if there's enough ACH can it stimulate action potentials, which are sudden spikes in signals to your adrenal medulla, which cause the release of epinephrine and norepinephrine hormones. Back to our analogy, the scout reaches the ganglia, and he goes to the head office, which represents the synapse, to deliver intel, which represents ACH. Now, the base won't take the word of one scout, but if multiple scouts arrive with lots of intel, or ACH, the head office will take action potential and command the release of their defensive soldiers, who represent norepinephrine and epinephrine, and a third base, which represents the adrenal medulla. Back to reality, epinephrine and norepinephrine are key parts of stress as they stimulate important functions necessary for survival, such as increased breathing and heart rate, glycogen breakdown in the liver, and dilation of pupils. At the same time, they inhibit less important functions for survival, such as digestion in your stomach and urination in your excretory system, things that won't help you survive now. So in a nutshell, your sympathetic nervous system stops these non-important functions that use energy to boost more important survival functions, which keeps you out of danger. Alright, back to the analogy. These soldiers that were released from the base have specific jobs in order to protect the base, or in this case your body. Some soldiers stimulate a better base defense by putting up barricades and getting more troops on guard, while some of them inhibit unnecessary parts of the base not needed for defense, like rerouting the power of the lounge to control centers. From there, the base is prepared to deal with any imminent threats, just like your body is prepared to deal with any imminent threats. However, as we evolved over the past years, we are now triggering our stress response to everything, even when we aren't about to die. Going into an exam unprepared can be bad, but in the end, you're still alive. That exam didn't bite off your arm, but your body's still prepared to fight that exam if it ever threatens you. This is due to your peripheral nervous system not knowing the difference between life or death, because psychological responses to non-immediate stresses are largely the same when you're fighting for survival. If this is your constant life, it can cause some nasty side effects like digestion problems or urinary issues and even the suppression of your own immune system. It would be painful to live like that all the time, and to understand how we can stop feeling stressed like that, we must explore the parasympathetic system. These systems counteract each other. While the sympathetic nervous system activates when you're stressed, the parasympathetic nervous system happens when you aren't stressed. It not only calms you down, but it also helps you digest food, reproduce, excrete real waste, and fight off infections. Ways you can promote this are through meditating, relaxing, or eating comfort food. However, to do the business of living, our bodies must maintain a balance of these systems, and instead of working against each other, both systems work together to maintain homeostasis in our bodies, which just means a balance in our bodies. It's like how a base cannot be in a defensive state constantly. If the soldiers went into lockdown mode every time they think they see a threat, it would be exhausting and stressful for them to constantly be on guard, and they will neglect their own rest, which is very unhealthy. Similarly, if the soldiers let their guard down constantly, they would easily get raided and the base would be destroyed. So to maintain a base, a balance of defense and self-maintenance is necessary for survival. Let's get a recap of everything. We've acknowledged that short-term stress is a natural defense mechanism to keep us safe. We know that it comes from our sympathetic nervous system. We learned how neurotransmitters play a role in short-term stress, and how it travels through our body, from our sensory nerves to the hypothalamus, to the ganglia, to the adrenal medulla, all the way to our effector muscles. We also found out why we experience stress when we aren't in danger. We learned about the parasympathetic system, which counteracts stress, and ways of coping with stress. As Mr. Ahern once said, to truly deal with stress is to understand how stress works in your body. So, with this knowledge, I hope you all enjoy a stress-free life.